Nvidia makes some of the most powerful chips in the world. These chips are used for artificial intelligence, data centers, and advanced computing. Companies use them to train AI models, run large systems, and process huge amounts of data. The US government believes that these advanced chips could also be used for military purposes. So, to limit China's access to this technology, they introduced export controls. This means Nvidia cannot freely sell its most powerful chips, like high-end AI GPUs, to Chinese companies. To deal with this, Nvidia even created slightly less powerful versions of its chips just to meet US rules and continue selling in China. But over time, restrictions have become tighter. The reason behind these restrictions is linked to national security concerns. Advanced computing hardware can be used not only for commercial applications, but also for defense systems, surveillance technologies, and strategic research. By limiting access to such hardware, the US aims to control the spread of high-end computational capabilities. From a technical perspective, the restricted chips are those capable of handling large-scale parallel processing tasks efficiently. These include workloads such as machine learning training, simulation modeling, and advanced data analysis. Without access to these chips, certain types of high-performance computing become more difficult to scale. For China, these restrictions create limitations in accessing the latest hardware required for advanced AI development. As a result, companies are adjusting their approach by optimizing software, using older hardware, or increasing investment in domestic semiconductor development. This has led to a noticeable increase in efforts to build local alternatives. Chinese firms are working on designing their own GPUs and AI accelerators, aiming to reduce reliance on external suppliers. While progress is ongoing, matching the performance and ecosystem of established players remains a complex challenge. The impact of these restrictions is not limited to Nvidia and China. The semiconductor industry operates through a global supply chain. Memory manufacturers, component suppliers, and equipment providers across different countries are indirectly affected by changes in demand and trade flow. For example, companies that supply memory chips used alongside AI processors may see shifts in demand depending on how many advanced systems are being produced and where they are being deployed. Another aspect to consider is the role of cloud computing. Instead of purchasing physical hardware, some companies access computing power through remote data centers located outside restricted regions. This allows them to continue running advanced workloads without directly importing controlled chips. While this does not fully replace direct access to hardware, it provides an alternative pathway for maintaining computational capabilities. From Nvidia's perspective, these restrictions limit access to one of the largest markets for AI hardware. However, global demand for AI infrastructure continues to grow, particularly in regions such as North America and Europe. This helps offset some of the impact, although market dynamics continue to shift. Over time, these policies are contributing to a more regionally segmented technology ecosystem. Different countries are focusing on building their own capabilities in semiconductor design, manufacturing, and software development. This shift is gradual but significant, as it influences how technology is developed, distributed, and used across the world. In summary, the so-called Nvidia ban is not a complete prohibition, but a targeted restriction on specific high-performance chips. It is based on defined technical thresholds and is part of a larger strategy to regulate the distribution of advanced computing technology. The effects are visible across multiple levels, including hardware supply, software development, and global trade patterns. As the demand for computing power continues to increase, these restrictions are likely to remain an important factor in shaping the semiconductor industry.